It's my pleasure to join you to talk about how we can power the clean energy transition that we all need. As we think about the greenhouse gas trajectory we were on, the red line, the business as usual path, we were excited back in Paris to sign the Paris Climate Agreement when the nations of the world got together and through their national direct commitments agreed to shave off about a degree of warming if every country did what they said, which of course is not exactly what's happened. That's half the story. The other half is that there's a whole set of needed innovations that we must also put into effect, where we need to develop new policies, new science, new technology, new human partnerships to really build out solutions so that overall we can not only reduce our warming to acceptable levels, but also take advantage of additional agreements such as the Kigali Accords that were signed 6 months after Paris that would shave off about another half degree. Now that's fine. In Paris, we agreed to 2 degrees of warming as the guardrail for humanity. But since then, the science has clearly demonstrated that we must make 1.5 degrees our target. And that's really why we need to pitch in on everything from innovating in science, technology, engineering, markets, and social processes. The reason for this is clear. Everyone has seen the graphs that highlight the dramatic changes in the Arctic, the fires in California and Australia, the Siberian heat waves, and all of these paint a dire picture. For me personally, the story is brought home with the fires in California that bring reasonably clear days, that bring wonderful solar to our 1 million+ solar panels, to the sort of climate apocalypse picture you can see here, which has dropped the output of my rooftop solar system to only 10% of what would be a regular day. It's all of these features together that really highlight that if we don't make 1.5 degrees an achievable target, we don't get any of the benefits. And in fact, from extreme heat to permafrost to ecosystems, we see massively more, 2 to 10 times more damage by that 2-degree target than the 1.5 degree, the stringent target we have to make a reality. This raises the profile for the states, the countries that have really made commitments. In California, we were on a path to be 50% clean energy by 2030. We've since upped that to 60% by 2030, on a path to 100% clean energy by 2045. That's the kind of goals we need to adopt around the world. Well, we see options of that. California will likely build 10 gigawatts of offshore wind, as New York will likely build. For us, that'll be 1/4 of our peak energy demand coming in a source of power for which we don't use any offshore wind today. That highlights the opportunities. Internationally, China has now committed to peaking their emissions by 2030 and to going to carbon neutrality by 2060. Those are the types of goals that make world-changing difference. United States, under President-elect Biden, has said that electricity will be carbon neutral by 2035, and the economy will be carbon neutral by mid-century. These are dramatic targets that highlight the degree to which we can change our economies if, like with the Paris Accord, we do what we say we're going to do. If we put all that together, what the US is now committed to, what China, South Korea, Europe has all done, we move from a band of expected warming of almost 3 degrees Celsius down to our optimistic scenario of 2 degrees. We still have to get to 1.5, but these types of innovations, these types of investments in clean energy will get us there. But a big part of that story has been left out, and that is through the Black Lives Matter movement, through the efforts to understand how we make clean energy and new technologies in general available to the affluent, not to the poor. We see time again places where, by not integrating social justice, we're making the climate story far harder than it has to be. So in the United States, my students and I have worked on a project to highlight the degree to which clean energy, if made equitably available to low-income people, people of color, people in poor attainment areas, we can dramatically accelerate that clean energy introduction. There's many ways to do this. We found that by highlighting where we don't invest in poor communities, we can dramatically turn around investments. We can bring attention to the environmental injustice, the systemic racism that we foist on many of these communities. And the opportunities to switch this is not just a domestic story. We're already seeing projects in Kenya and Bangladesh and Malaysia, all cases where former fossil fuel investments, in this case, a fossil fuel power plant proposed for Kenya, where the biggest investors, General Electric from the United States and the International Bank of Commerce from China, have pulled out. We hope they're pulling out of coal, but staying with clean energy in these countries. And that's one of the many areas where this conference can bring attention, can highlight the opportunities, and can really make the next stage of our clean energy process one that's far more equitable and far more rapid than we've seen so far. I want to thank you all for joining this conversation and to highlight the opportunity to follow individual projects, but also to really take part with your local non-governmental groups, industry, academia, and others to really raise the voice to make this clean energy transition also a just energy transition. Thank you very much. Welcome to our panel on decarbonization and the just transition. Before I introduce four amazing panelists, I just want to set the stage a little bit. The issues around Black Lives Matter and the recognition of social injustice and of systemic racism have really highlighted a number of features that we saw come to the fore during the current presidential campaign. Not only has President-elect Biden highlighted the degree to which the United States will invest enough to make the clean energy transition rapid enough for climate reasons, meaning we'll get to clean energy by 2035. But he's also directed his team to invest 40% of all federal money to benefit disadvantaged communities. That will catalyze between $2 and $5 trillion in investments, a dramatic change, and the Build Back Better campaign slogan that we've heard from President-elect really highlights in a number of ways, from highlighting environmental justice in terms of hiring to impacting which communities we can target for new investments, to finding opportunities to reintegrate the United States into the Paris climate agreements. All of those features we hope will have a transformative impact on the US economy, but they'll also change how we think about the impacts of energy and our choices, not only on the poor, but in terms of racial equality as well. We've seen some high-level campaigns, such as the effort to identify the degree to which continuing investment in fossil fuels differentially impacts children and children of color in particular. And in this panel, we'll highlight all of these issues, from the technical aspects of the energy transition to the opportunities to make this a clean and just transition and to sustainably manage the planet. So I look forward to your conversation and comments, and I'd like to introduce the panelists now. For this panel on decarbonization and the just transition, we're joined by credible leaders in the field. From Project Drawdown, Dr. João Pedro is going to discuss the scenarios that Drawdown has developed to look at low carbon and decarbonized scenarios. Professor Shalanda Baker from Northeastern University and the Energy Justice Project is going to examine how we can utilize the clean energy transition to invest in those communities that we've marginalized in the past. Professor Tom Richards from Penn State will examine how a bioeconomy can or cannot contribute to a just energy transition. This is a remarkable group, and I am so pleased to have them with us today.
Hello, my name is João Pedro Gouveia, and I'm a senior fellow for Project Drawdown on the Energy System Solutions, and at CENSE FCT Nova University of Lisbon in Portugal. I'm also a board member at Drawdown Europe Research Association, and today I'll be talking about Project Drawdown decarbonization pathways on looking deeper to the energy system solutions. So we know that the energy systems related emissions account for 75% of all greenhouse gas emissions, the bulk coming from the power sector, 25%, followed by 21% on industries, 14% in transportation, and 6% on on-site generated emissions in buildings. We also know that the current global electricity generation mix is delivered mostly by fossil fuels. Coal, oil, and gas still represent around 65% of all electricity generated. Hydro systems around 16%, and the rest coming from smaller renewable energy systems and nuclear. Drawdown solutions represent less than 20% of the current generation, so there is a lot of margin for growth in the future. So you can see here one of the graphs we have developed at Project Drawdown that shows the estimation of impact of each solution. So being the two circles on in each one, the result of the variation of the two scenarios we have assessed in the latest review. So one, the 2-degree target, and the other one more aligned with the 1.5 target scenario. So we have organized the electricity solutions around shift production, so more on the generation side, and then enhanced efficiency solutions on the demand side. So on the shift production, of course, we have the integration of more renewable energy sources that are replacing conventional technologies as coal, oil, and gas power plants. So we have onshore wind turbines, we have small hydro, we have concentrated solar power and geothermal. And then on enhanced efficiency, we cover LED lighting, smart thermostats, building automation systems as an example. Another critical sector on this energy systems solutions are, of course, transportation. So we organize them 13 solutions around 3 different clusters, shifting to alternatives where we have, for example, bicycle infrastructure, electric bikes, or carpooling. And then we have enhanced efficiency, where we cover efficient ocean shipping or hybrid cars and efficient trucks. And electrification of transportation, also important, where we have solutions like electric cars and electric trains. Covering buildings, we have also organized them in 2 clusters, enhanced efficiency and shifting energy sources. On shifting energy sources, for example, we have improved clean cook stoves or high efficiency heat pumps. So industry, I'm not talking here because it was already covered by another presentation on circular economy. Looking to the results, we see that this figure shows the ranking of the solutions by 2050 according to their emissions avoidance impacts. So the cumulative reduction between 2020 and 2050 of the top 20. And we understand that 8 of the top 20 are related to the energy systems in both of the scenarios we have evaluated. So for example, we can see on rank 6 wind on onshore turbines, but also we can see several solar solutions that bundled together could be on the top 3. So utility scale solar, photovoltaics, distributed solar photovoltaics, or concentrated solar power. Looking to the top 40, we see the same pattern. So half of the top 40 are related to the energy systems, for example, with 5 on transportation, 6 on buildings, and the majority of the rest around the power sector. Both drawdown scenarios unfold 100% renewable energy generated electricity, and we understand also that 76 solutions included in the latest review, roughly 30% reduce the use of fossil fuels by enhancing efficiency, or and almost 30% replace them entirely by alternatives. So together, these combined solutions of the energy system can provide almost 2/3 of the emission reductions needed to achieve drawdown. I'll leave you here now with a couple of insights to understand really the potential for the future growth of the solutions and the amplification of the speed of decarbonization on this sector. So solar PV module prices have fallen by around 80% since 2009. We see similar patterns on wind onshore with 30 to 40% reduction since 2009. We also see that, for example, offshore wind power is only focused now on Europe and China, so with a lot of global markets to expand on. Also from our assessments, we understood that geothermal, not being on the top solutions, we see that where good high temperature resources exist, geothermal can be a very economical source for baseload power. We also see from the statistics, of course, that ocean power and concentrated solar power are the renewable energy technologies with the lowest total installed capacity. So also a lot of margin there for exploitation of those renewable resources. Recent news, so battery pack prices are already cited below $100 per kilowatt hour for the first time in 2020. We see around 90% decrease on battery costs and prices from 2009. It's important not only for managing the power sector, but also for the integration in the transportation sector. We also seen in the last year that renewable energy is resilient to COVID-19. So the capacity and generation coming from renewable energy is decreasing, with coal and natural gas are getting out of the picture in some locations. So what we understand is that the majority of climate solutions either reduce or replace the use of fossil fuels, and we must accelerate these solutions while actively stopping the use of coal, oil, and gas. As a final message, I would like to say that we must look to all these sectors within the energy system for a long-term decarbonization pathway where technological, regulatory, financial barriers need to be overcome for a fast-paced development and a systemic change. Thank you.
Hello, I'm Tom Richard, and I'm a professor at Penn State University. I'm going to be talking today about negative carbon bioenergy and asking the question, how can that be done, or can it be done sustainably? And I want to point out that this is not really decarbonization, which there's a lot of talk about and interest in through Drawdown, but recarbonization in a different way than has been done in the past. So first, I want to remind everyone that, and this is really a founding principle of Drawdown, is that we need negative emissions. Simply reducing the greenhouse gas emissions that we're putting into the atmosphere is no longer sufficient. There's too much CO2 and other greenhouse gases in the atmosphere. We have to draw that down, and that will require a very substantial amount of negative emissions over the next decades. That's an industry that doesn't really exist yet, other than the natural processes that I'll talk about shortly. So this is an illustration from an article by Jan Minks and others out of the Mercator Institute and Leeds, where Jan is now, on a range of negative emission strategies. And some of these are technological, some of them are in the category of what are called natural solutions. I'm going to focus on the green box, which are a combination of regenerative agriculture and some forestry, along with bioenergy, carbon capture and storage, and sometimes co-products like biochar, and of course the potential for the cropping systems to sequester carbon in the soil. I do want to remind us that photosynthesis has been the way that atmospheric CO2 has been drawn down for over 3.5 billion years now. It's what's given us the atmosphere that's livable for us with oxygen, and it's maintained the CO2 levels at a very low concentration for a very long time. That has gone up, as we all know, in recent decades, and many of us have seen the Keeling curve, which this is just the last 2 years of, taken at the top of the Mauna Loa volcano in Hawaii. What many people don't know is that curve is actually a sawtooth, and that in addition to the positive emissions illustrated in the red arrow, every year there are substantial negative emissions, and during the summer and into the fall, those negative emissions caused by photosynthesis, taking CO2 out of the atmosphere and growing plants, actually overwhelm the positive emissions and help us to achieve a much smaller net increase every year. So the idea is that we need to think of ways to increase and accelerate that photosynthesis in ways that are sustainable and maximize the benefits of that CO2 that is captured by plants. Now, there are a wide range of natural climate solutions that are illustrated here by an article by Griscom et al. A few years ago. And you can see that some of those are very substantial, potentially in the individual ones and some in the single digits, such as reforestation, but collectively, perhaps in the tens of picograms of CO2 equivalents per year, or gigatons, as many of us are used to thinking about this. Many of these natural solutions also interface with bioenergy, carbon capture and storage, and bioenergy systems in ways which can be positive and synergistic, or sometimes not. And again, the differentiation between those is important. I hope we can talk about that during our open session on Friday of the conference. So an important part of biomass energy systems being a negative carbon solution includes something called carbon capture and storage. This is a technology that's been developed for the fossil fuel energy industry. A lot of people have concerns about the application in that particular sector, but the basic approach can take atmospheric carbon as well as fossil carbon and put it into long-term geological storage, as well as other positive potential values, including chemicals and biomaterials. And I'm not going to take the time to go through this schematic in detail, but I just want to point out that there's potential for carbon storage during the crop production side of a biomass energy system, and also in the conversion process. And the combination of those two things offers some opportunities to put CO2 in soil, in chemicals, in biomaterials, as well as in deep geologic storage. The scale of that is substantial. And this is just an illustration out of an article that John Field and colleagues, including myself, published a few months ago in looking at different types of natural vegetation alternatives, illustrated here in the left, versus a bioenergy system that includes carbon capture and storage. And in this case, some offsets for fossil energy, which are illustrated in gray. And if we look at those carbon benefits on a per hectare basis and compare them with grassland restoration or reforestation, the two bars on the right, we can see that if we develop the technology for biofuels and biomass production in ways that really tackle the carbon benefits, we can have substantially more of those benefits from these technical coupled with natural systems than the natural vegetation alone. And that ratio for advanced technologies relative to the natural vegetation can be as high as 5-to-1 in forest, as high as 14-to-1 in grassland systems, rough parity with current bioenergy technology, and in grassland systems, potentially 3 times as high right now. So these are areas which require some additional R&D and development, but they also require us to think hard about sustainability. And I wanted to just close by recapping some of the work that was done by Whitehall and others in the Newfield Council on bioethics, that the development of bioenergy systems should not be at the expense of essential human rights, including food, health, and water, should be an environmentally sustainable system. And again, we can talk in a great deal in the discussion about that. Both of those are really important issues. Has to contribute to a net reduction in total greenhouse gas emissions. Otherwise, there's really not a lot of point in my view. Should adhere to fair trade principles with equal distribution of costs and benefits. But if these things can all be achieved, and I think they can, although they won't necessarily be, then there is a duty to develop such biofuels in a way that respects these principles. Thank you.
Hi, my name is Shalanda Baker, and I'm a professor of law, public policy, and urban affairs at Northeastern University in Boston. And today I'm going to talk to you about energy justice. The public lynching of George Floyd in May of 2020 sparked global protest and a deep reckoning with racial injustice and structural inequality. But I would suggest to you that the energy system itself is not immune from this deeper reckoning with structural inequality and structural racism. And in fact, it is complicit in the violence that is routinely experienced by Black and Brown people in this country. And the same ways that Black and Brown communities are fighting for breath as a result of the oppression within the criminal justice system, they are fighting for breath as a result of the oppression that is embedded within the energy system in this country. But there is a way out of this, and that is energy justice. And so before I get to that, I want to talk about a couple things. Today, I'll talk a little bit about the energy transition. And by energy transition, I mean the transition away from fossil fuels to clean energy that is happening on global dimension and a global dimension, as well as a local and domestic dimension. I'll also talk about energy justice. I'll introduce that as a theoretical framework and a framework for praxis, which is to say an approach to advocacy on the ground. And finally, I'll end with a cry, a plea, an argument that energy justice should be our approach to energy policy in this particular moment, as we are transitioning rapidly away from fossil fuels toward clean energy. So in the fall of 2016, I had the opportunity to serve as a Fulbright scholar in Mexico And I was living in Mexico City, and I was invited to a meeting hosted by the Mexican equivalent of the Secretary of Energy. And so the Secretary of Energy had invited stakeholders and members of civil society to a meeting to discuss shared benefits connected to clean energy developments in the country. So again, academics were invited, members of the NGO community, and other key stakeholders. But as the meeting started, a group of indigenous people from Oaxaca, Mexico, filed into the room because unfortunately, the Mexican Secretary of Energy had not invited them to the meeting to discuss benefits that connected directly to their communities. And so these individuals from who filed into the room were from a place called Oaxaca. Oaxaca has been identified by the US Department of Energy as one of the windiest places in the world. It's also home to no fewer than 14 distinct indigenous groups who speak indigenous languages. And they are also farmers and fishermen who rely on the land to support a subsistence way of life. Oaxaca is now home to around 2,200 megawatts of installed wind capacity and around 24 distinct wind energy projects and developments in this very small region. It is also a place with some of the densest wind energy development, large-scale wind energy development in the world. And as I mentioned, the people here are indigenous and they rely on the land. And unfortunately, they've received very few benefits as a result of this development. And so that's why they marched into that meeting in Mexico City. They marched in for recognition justice, so a recognition of their unique lived experiences. They marched in for procedural justice, to be engaged in the process of creating the energy system that would so deeply impact their lives. They marched in for energy justice. And so what became clear to me in studying and analyzing the Oaxaca story is that as long as we're relying on the same logics and approaches to development, to clean energy development, that we relied on in the fossil fuel development, in developing the fossil fuel system, we are bound to replicate the inequality that is baked into the fossil fuel system. And so those logics are the logics of extraction, the logics of dispossession, and the logics of exploitation. And so I think we can do development, energy development in particular, in a different way. Domestically, we're seeing some of the same dynamics play out. So I had a front row seat to Hawaii's energy transition. From 2014 to 2017, I was a law professor at the University of Hawaii School of Law. And that time period was a remarkable time period when the state was embarking on one of the most ambitious clean energy transitions in the world, and especially in the country. And so the legislature passed a bill to meet all of the state's energy needs using clean energy by the year 2045, and that was signed into law in 2015 by the governor. And in all of my conversations with stakeholders, energy stakeholders around the state, I would ask, okay, where do communities fit into this dynamic? And they would respond immediately that the energy transition was purely a matter of technical changes and a switch from fossil fuels to clean energy. But I knew, based on my research in Oaxaca, as well as the experiences and lived reality of folks in Hawaii, that energy was so much more, and the transition had so much more potential. People in Hawaii pay the highest cost for electricity in the country. Dirty energy is concentrated in Black, Brown, and Indigenous communities in Hawaii. And so the energy transition that that state is embarking on has the potential to transform Hawaii and transform the social and economic circumstances of Black, Indigenous people and people of color in that state. But that's only if energy justice is embedded in policy approaches. So what is energy justice? Well, it has several elements: distributive justice, procedural justice, and recognition justice. So distributive justice is ensuring that the goods and bads of the energy system are equitably distributed. Procedural justice is what I talked about earlier with respect to Oaxaca. Procedural justice means that people have a meaningful seat at the table and a meaningful say in shaping the system. And recognition justice is a recognition of the harms that individuals have faced. Restorative justice is interesting, and that's the arrow at the bottom there, and that refers to the true healing potential that can come from energy policy. Energy justice is deeply connected to climate justice and environmental justice. And that is to say that we can't have energy justice if we're replicating environmental harm. We can't have energy justice if we're not making communities more resilient in the face of climate change. Energy justice also must center the voices and experiences of frontline communities. And so those are the communities on the front lines of environmental injustice. Those are the communities that are on the front lines of climate change. It must be anti-racist and anti-oppression. And again, energy justice has the potential to create transformation through energy policy. Energy justice is praxis. So that is to say that folks on the ground are deeply embedded in this work of creating a more just energy system. And so energy justice requires that those communities are deeply embedded in those conversations concerning the transition of the energy system. Energy justice is deeply connected to its activist roots in environmental justice, which is a movement that emerged out of the 1980s and 90s, as well as climate justice, which is a movement that emerged in the 90s and 2000s, early 2000s. The same communities and individuals are embedded in these particular conversations, and they are also embedded in energy justice and the crafting of energy policy. So in closing, energy justice is a framework for this moment. We are reckoning with the harms of the past. We are reckoning with structural inequality and structural racism. As I mentioned, the energy system is not immune from this deeper reckoning. Energy justice is an opening to create an energy system that stops killing people, that is no longer disproportionately harming Black and Brown people in this country. We need a system and an approach to creating the system that is deeply embedded in the principles of distributive justice, procedural justice, recognition justice, and most of all, healing, restorative justice. Frontline communities have to be central to this transition of our energy system. And I've written a book about this called Revolutionary Power, which will be out in January. I hope you check it out. And here's a discount code if you decide to do so. So thank you so much for your attention today. I look forward to the dialogue.